Dumb joke, and I don't care. I love that joke. I'm sure that joke exists, but I just made it up now. But I'm sure somebody else has said it. That boy ain't right. So, the basic idea of inverse functions, for them to exist, we had to restrict the domains, which leads to, for the inverse function, domain becomes range becomes domain. So because we had to restrict the domains, the ranges of the inverse functions are exactly the same restricted. So what does that mean for us? That means, for example, when I see a question like this, I think about it backwards. If I ask you, what's the square root of 81? You think, what do I square to make 81? You think in terms of the original. The square root is an inverse of the square. Same thing here. You think in terms of sine. What would I take the sine of to get a half? That's the thought process. And of course that would be pi over 6, because sine close to the x-axis doesn't like it there. It's going to be the smaller output. The weirdness comes into play. Like, for example, if this would have been sine inverse of negative a half, what would have been different? Fourth quadrant. So just to get there, so instead of going to pi over 6, I would have gone to negative pi over 6. So for inverse sine, the output has to live between negative pi over 2 to pi over 2. So if I have an inverse sine of a positive number, I'm in the first quadrant. Everything is good. The world is great. Yay. If I have a negative input, shit, gotta slow down. I'm in the fourth quadrant, and the great thing is I just put a negative sign on what the angle would be. Let that be nice. Cosine is an asshole. We're going to see more proof of that eventually. What quadrant's going to live in for the output for inverse cosine? Yeah, which quadrant's going to live in? First and second. So what angle makes cosine rad 3 over 2? The cosine of what is rad 3? Let me ignore the negative sign for a second. How do I make cosine big? I stay close to what axis? I love you guys. So remember, sine likes y, cosine likes x. If I want the output to cosine to be the bigger thing, I want to be close to the x-axis. Yes? And what's closer to the x-axis? Which angle? Pi over 6. How do I make an angle smaller when it's radians? I divide by more. So pi over 6 is smaller than pi over 4, is smaller than pi over 3, is smaller than pi over 2, yes? So if I know, so again, it's always interesting to me because I'm not sure if you guys are just, well, some of you are very shy, I get this. But I have to tease out, do you understand it and you're shy, or do you not understand it and that's why you're looking at me hoping I should say it? When I give you a problem and I say like, cosine of what is 1/2, for example, you say to yourself, okay, cosine x, I can't be close to the x-axis because it's small, I must be far away from it. Pi over 3 is far away from it. Because what would rad 2 over 2 be? Pi over 4, because that's the one where I start in the middle. So rad 2 over 2 is its own thing. Let that part be easy. Okay. So this is going to be pi over 6, but that would be if it was positive. What quadrant must I be in that's the only other one I could be in for inverse cosine? I could only be in the first and second quadrant, so I must be in the second quadrant. The reference angle must be pi over 6. So what's the actual angle? Pi over 6. So that's the trade-off. The reason inverse functions exist for these is because we cut the domain to make it exist, to make it pass horizontal line test. That's a trade-off. They exist now, but they can't handle certain things. They can only live in certain areas. Just like a square root can't give me a negative number answer because I had to chop half the damn parabola off. It's not the poor little dude's fault. We're not going to redo this whole worksheet, by the way. The other kind of problem are these. If you weren't here yesterday, these should look very strange. I would guess. But to remind everybody how these work, what is an inverse trig function? What is it? Besides weird. What does an inverse trig function tell me? What's a log mean? What's that represent?
A number.
No, it represents the power, yes?
Right.
That is the power that E needs to become 7. Do you have to know all the extra detail? No, you just should remember that logs are powers. Why did I make a big deal out of that? Because properties of logs are the exact same as properties of powers, which should hopefully make it easier for you to remember them. So the output to a log is a power. So how do I kind of like shorten that? A log is a power. What is the input to a normal trig function? What do we normally put into a trig function? What's an angle. So what's the output to an inverse trig function? If the input to a function is an angle, what's the output to the inverse function? Angle. The input to a function is the output for the inverse. That's what happens. They switch the inputs and outputs, yes? If I have a function whose input is an angle, the inverse function has an output that's an angle. Because what's an inverse function do? Switches the inputs and outputs. Let that make nothing but sense. That's why the first few problems we were doing, the answers were angles. Because the output to an inverse trig is an angle. This is an angle. Can somebody tell me anything specific about the angle? I don't know. I don't want to know what the angle is. You couldn't tell me that without plugging the calculator. And I don't want us to plug it in the calculator. Can we draw and label the triangle that this angle lives in? Do we know anything about the triangle? Hell yeah, we know a lot of shit about the triangle. What do we know? We know it's got 3 sides, Jeff. Yes. 11 is the hypotenuse. How the hell, don't say anything. How the hell did he know that? Look at him. He knew that shit. And he knew it. How did he know that? So, the input to a trig function is an angle. So the output to an inverse trig function is an angle. The output from a trig function is a ratio. Yes? We've known this from the beginning. We made the ratios before we even named them trig functions. So we know that. So what's the input to an inverse? A ratio. What is the ratio secant is related to? No, because secant is related to which one? Secant is 1 over cosine. S goes to C. C goes to S. Secant comes from cosine. Cosecant comes from sine. So secant's related to cosine. Cosine is which side? Cosine likes x. So cosine is x over h. So what's secant? It's h over x. Okay. And one other little thing that you can always do. If the secant of the angle is 11 over 6, what's the cosine of the angle? 6 over 11. Don't overthink it. That equals that. They both talk about the exact same angle. So if I give you an inverse secant, cosecant, cotangent, you can automatically make it into its reciprocal. Just flip the thing inside. We know how it works. What do they do with the ratios? They flip them. So if I don't like inverse secant, don't like the looks of him, make it inverse cosine, but do what we always do. Flip the ratio. That's what they do. Does that make sense? That makes this much simpler because now you can always only work with the 3 primary trig functions for inverses. Okay, maybe. So what if I want to know the tangent of the inverse secant of 11/6? Can I get that now? What am I missing? Yeah, I'm missing the y. So if I just use old Greek dude, 121 minus 36 is 85? I think that's right. Yes. So what's the tangent?
Square root of 85 tangent.
Yes, it's y over x, yes. So all these problems, here we got that. All these problems right here, they're all exactly the same problem. The inside tells you the ratio, you make the triangle, you put the numbers, and you see what you need to answer the question on the outside. Those are all the exact same problem, which is the first problem we did. The very first problem we did with trig is exactly what this leads to. It just looks worse. But a lot of math is just, can you translate what they're asking you? Can you make it better? So all this is asking you is, what's the tangent from the angle in the right triangle where the x is 2 and the hypotenuse is 5? Okay, I can draw that. I can answer that. That's really easy. But if you look at that, you don't know how to translate it, you ain't going to know what to do. You're like, what does this do to this? I mean, can you imagine that? If you see this, you're like, what do these do? Holy shit, that would be horrible. But we don't have to look at it like that because this is an angle. I can draw the triangle. Okay, maybe. Now, real quick, let me do a little side note that I haven't done yet. What do you guys think this would be? This requires unbelievably little work. Yes. Because what does a cosine and an inverse cosine do to each other? Cancel. Now, here's the one place this doesn't work. What if I change the order? This doesn't feel like it should do anything weird. What are you gonna do, Jeff? Yeah. There, yeah. Now, okay. Do you guys, everybody cool with the first one? When the inside's an inverse, it's nice, you can just kill those, yes? There is a problem with this. There's a problem with that. You can't just kill them. Why can the answer not be 3 pi over 4? What is the function on the outside? This is an inverse sine problem, yes? The inside happens to be a sine. I don't give a shit. This is the inverse sine of something. What did we say the answer has to live between for inverse sine?
-1.
No, that's the input for inverse sine. What's the output for inverse sine? Gotta be between negative pi over 2, yes?
Yeah.
Goodness, I really want you guys with me. This is a trippy little side note. And I think that shows up in the homework, but it's not that big of a deal. The answer can't be 3 pi over 4. Because the inverse sine cannot give us answers that are not in the first or fourth quadrant. Sine of 3 pi over 4, would that be negative or positive? Would the sine of 3 pi over 4, what quadrant is 3 pi over 4 in? What quadrant is 3 pi over 4 in? Second. Is sine positive or negative there? Positive. So how does sine of 3 pi 4 over 4 relate to sine of pi over 4? If you draw yourself a picture, here's 3 pi over 4. How does this relate to this? So the answer to this is pi over 4. Because the answer can't be 3 pi over 4, but it has to be an angle that would make the SIGN the same. So that's the trade-off. If I'm doing an inverse sine, my answer cannot be anything outside of negative pi over 2 to pi over 2. It can't be. Yeah, I know, you're going to spell it now. I know. Because sine and sine and stuff. Shit. What's the sine of the sine? That's a little side note. If you don't totally get that, it's not the end of the world. But if you have an inverse sine problem and your answer is outside of negative pi over 2, you've made a mistake. Okay. And then the last kind of problem was these down here. I brought my calculators today, which is great. But I'm pretty sure we finished this, but for example, if I did the tangent of b is 5 over 12, how do I solve for b? How do I kill tangent? And here's the terrible thing. Dear God, I'm going to do something very bad. I'm going to do something really bad. All right, and you know I've seen this. You know I've seen Calc 3 students do this. And then I go into my little corner at home. I got a weeping corner. I go into my little corner and I huddle down and I weep. And then I get over it. But, dear God, this is not tangent times b, yes? How do I kill a function? Whose job is it to kill a function? Take the inverse of both sides. I'm not multiplying, I'm taking. Because what do these do to each other? Kill each other, yes. So now I can just throw that in the old calculator. Right? So, let's see. I think yesterday I didn't have a calculator with me. I think we did this, didn't we? Somebody did this for me or something? I can't remember. So there's your inverse tangent. Right above tangent, that's crazy. And then I don't know what, I'm probably in radians. Yes. But if you want the answer in degrees, you go to degrees. You tell the calculator, do that again, and then it gives you degrees. Yeah, we did that. I remember that number. Yeah. So now I have the ability to find the angles if I know the side lengths, which is neat. It's a good thing to be able to do. Okay. I love you guys. So these are the main kind of problems you see from me. Very specific numerical problems. Very specific kind of need you to make a triangle kind of problem. Yes? And then this is just, can you set it up so you can throw the right thing in the calculator? Can you pick the right trig function to relate what you know and what you want to know? Okay. How are we feeling out there? Okay. 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 So what we're going to do today, the thing I want to focus on today is, like I just said earlier, I want to extend trig to work beyond just right triangles. And I was going to use the lecture book, but I sort of have a bunch of handouts that do this anyway, so I'm not terribly nonplussed about the lecture book right now. Yes. Okay. So let's do this. I have a little, you're not going to believe this, but I have a worksheet for you guys to work on. Here's how this is going to work. So I'm going to draw a very obviously not right triangle. Yes? And I'm going to say it's not equilateral either. Maybe this is 62 degrees and this is 57 degrees, but yes, you guys with me? So it's just some triangle in the world just trying to make its way, and I caught it and I put it down here. Is this a right triangle? No, you just said no, Jeff. Okay. But let me just pick, if I call this angle C, what's this side? Huh? Yeah, side little c. If this is angle B, what's this side? Little b. And if this is side angle A, this is little a. Okay. That's crazy sauce. You guys all with me? That's amazing, Jeff. So in general, to make this easier, I just, whatever I call the angle, I call the side opposite of it the lowercase version. Which is why with these kind of problems, we don't use Greek letters, because I don't want to get into lowercase Greek. I'm not going to make this a Greek alphabet class all of a sudden. And lowercase Greek is weird. Here's uppercase sigma. Here's lowercase sigma. Look at that. No, yeah. Okay. So here's what I'm going to do. We have done this kind of thing before. Can you create right triangles easily? In fact, we did almost exactly this. When it was an equilateral triangle, yeah, just drop altitude down, drop the height. I'm going to call it H because I'm crazy. How many right triangles have I made now? 2. Can you guys, which angle is not in either right triangle? A, good. So forget about it. Can you guys write an expression using sine for either of the right triangles? What I'm really asking you is, what is the sine of C? What's the sine of B? Take a minute. See if you can get what's the sine of C, what's the sine of B. So when you're doing C, you're looking at that triangle. When you're doing B, you're looking at that. So I want to know, I don't want a number, I just want to know from the triangle, what are these? Yeah, Rodney.
If we know the initial angle of A, why can't we use that at all after we?
Oh, no. So be careful. If, I should have made this. I'm trying to stay away from, normally when I try to draw like a non-right triangle, this looks like it's a right angle. So I try to make, I should have made it not look equilateral at all. Because if it's off kilter, when I drop this down, I did not cut that in half. The only time it cuts it in half is if it's perfectly symmetric, and that's only going to happen with an equilateral triangle. Is that right?
Yeah, it's fine.
That I think is your point.
Yeah,
Yeah.
it is. That still looks like a right triangle, which is fine.
Yeah, this one.
Yeah.
See, I can't. Okay. That's an issue with me. One of many. So, do you guys understand what I'm asking here? This is a very, very, very fundamental, easy question. What is the sine of C? H over B. Yes? Okay. And what's the sine of B? H over C. Is that cool? H over C. Tangent would be like H over part of A. We're not going to do that because I don't know how long this is. Can you solve, take a minute, I'm going to number these. Can you solve each of those for H? Don't say anything. I want H by itself. I need your help with this proof because I'm an old man. I know how it works. They're both very straightforward. Is that agreed? How do I get this solved for H? What do I do to both sides?
Take the inverse sine.
No, I'm not trying to solve for C. I'm trying to solve for H. Why is H not by itself? It's being divided by B. So how do I kill the B? Multiply by B. So what is H from this one?
B sine
B sine C. What is H from this one? C sine B. Okay, is everybody with me? I haven't done like a ton here, right? I haven't really done a lot. Go, Jeff, look at you. Waste a lot of ink, you've done nothing. But here's the neat thing we haven't done until today. Before today, we've done everything we've done up here. Everything we've done up here, we've done this in some way. We've done all of this. Here's what we've never done. Do I have two expressions that involve H?
Yes.
Do you agree with me that if H equals this, and H equals this, then what's true about these two things?
They're equal.
They're equal. You guys with me? If Layla's as old as Trent and Trent's as old as Ronnie, then Ronnie's as old as Layla. It's a stupid thing. So if this equals this and this equals this, then these two things have to be equal to each other. Okay, so far you're like, just like a math person. Dear God, he's just playing with letters. Can I leave and come back when you're done playing with your letters, Jeff? No, you can't. How? I can reorganize this a little bit. And right now, it's not going to make the most sense in the world, but can't I divide this by B? Can't I divide this by C now? Okay, now that looks neat. Do you guys see that? That's got a little more symmetry to it, yes? Are you guys at all with me here? We're discovering, what have we discovered? Is everything in that expression related to our original non-right triangle? Everything in this expression is related to our original non-right triangle. Are you with me? Because we got rid of H. H was the only piece that was not a part of the non-right triangle. So for every triangle In our geometry, this is a true statement. This is just simply true. Now, what's really neat, and I'm not going to do it, I could do it, but I'm not going. If I turn this around and I do this, I can do all the same shit. And what happens is, I get this is equal to all this stuff too. Because I did B and C. I could turn it around and I could do A and B. And I can get those related to each other. And if sine C over C equals sine B over B, and sine B over B equals sine A over A, then all this shit equals each other. Same thing with the Layla and the trend, the Rami and the H. Yes, okay. Math people, being remarkably creative, we said, oh, that looks important. Let's call it a law. Let's call it a law. And it's got signs in it. We'll call it the law of science. What do you guys think? And everybody's like, what'd you say? Sounds good. So we call this the law of science. Law of science. Hiya, hiya. So I'm going to do, oh, actually here. Perfect. So I'm going to give this out to you guys. Don't worry about, how many people do I have? 2, 4, 6, 8, 9. Man, my streak of even numbers is over. This is not bad. Okay. Don't worry about the little animals and various things. You want to be in a group, Christine? You can be in a ringer for a group. Maybe I'll be in a group. Somebody want me in that group? I'll just mess up on purpose. There you go. You're welcome. Okay, so let's do these two together, and then if you haven't figured this out yet, does anybody have one of these guys?
Yes.
Who has this guy? You have it too? No. Who else has this guy? Somebody else has to. I love you guys so much. Oh, you do? Oh, you do? Okay. Did you want to be, I don't know if you should be in a group or not. I don't know. We'll figure it out. Okay. So eventually, go ahead.
Sorry, can you last page?
Oh yeah. So the little guy, whoever you have in the corner, is going to be how I put groups together. Yes. Okay. Oh yeah, that's right. I'm only have 2 in a group. We'll figure it out. I'm not going to put you in a group. I need you all. When we get to it, we'll figure it out. So let's do these first 2 together, so you can get a feel for how the hell this does a damn thing for me. Now you all experienced this. What triangle did I do this with? Every triangle in existence. I could draw a completely different triangle and do all the same stuff we just did. I can make the height. I can call this A and this. I can do all the same stuff we just did, and it would come out the same way. I just had to give us some triangle to look at. Yes. So this is true for which triangles? Every triangle.
Every single one.
Every triangle in the whole universe. And just to really, let me think. No, I'm not gonna. So let's do these first 2. Can you guys kind of roughly draw this out? And you don't have to make it perfect. You're not gonna get a little protractor. Are you guys with me? Do you guys remember protractors? Do you guys know what those are? They're like the little half circle things with the little angles in it. Okay. I could go next door and get us some protractors, but I'm not going to. So like, if I want to put A over here, 41 degrees is a little less than 45 degrees. If I want to put, let me see how I want to do this. This would be 90, so this is roughly 77 maybe. So how much is this one? So this is A, this is C, here let me put it out here, and this is B. What is angle B? How big is angle B? How could you figure out how big angle B is? Yes, they all have to add up to 180. I've already got 118, yes? So what's left over for angle B If I got 118 already degrees in my triangle, what's left over for angle B? If it was 120, it would be. And then I'll give you another one. Okay, what do we got? 62.
One, or 62.
Yeah. You guys all with me so far? Your triangle doesn't have to be to scale, but it's kind of better if it is a little bit. Which side should be the biggest? Where's side C, by the way? Where's side little c? Yeah, down here across from angle C. Where's little b there? Where's little a there? Now, before we do any work, which side should be the longest? No? No? C. Whose mouth is biggest? C's mouth is biggest, so who's got the biggest stick I can put in his mouth? Side C could be the biggest. You guys see what I'm saying? You don't have to stop and do that. But at the end of this, you can do that. If I get C as 1 and A is 30, I'm like, I am very wrong because C should be the biggest freaking side. You can very quickly catch big mistakes. And they also tell me what? What else do I have that I haven't put on here yet? Now, here's the key thing. Here's the key thing about law of science. It sounds like a note you should take. When I slow down, that's a note. I should be taking notes right now for damn sure. I can apply law of sines when I can make a complete ratio. What does that mean? How many ratios are in the law of sines? How many ratios are right there in the law of sines? 3. If I can make any of them complete. So if I have an angle and the side across from it, law of sines should work, assuming I'm given enough information to do anything. Can I make a complete ratio with my triangle? What ratio can I make a complete one of? Sine A, yes. In which, so I can do this. Sine of 41 degrees over what? 10.5. So that's the A stuff, yes? That's the A stuff. Equals, and now it's up to you. What other ratio do I have some information about? Pick one. Yeah, sure, let's do C. What do we know about the C's? Do I know the side length? I don't know how long this is, but I do know the angle measure, yes? So sine A to side A equals sine of C to side C. Don't do that, Trent. I'm so tired. How do I solve this? All right, let me make sure you guys are really with me. Let law of sines be so stupid nice. As long as I can, if I have an angle and its side, I don't care which one I know, A, B, or C. As long as I know both of one of them, as long as I can make a complete ratio, law of sines will work. So what if I can't make a complete ratio? I can't use law of sines. What am I trying to solve for in this equation, of course? C. It's the only thing I don't know.
So if you put the first part in the calculator.
No, don't do that, dear God. Listen up. I almost called you guys kids. Listen up, kids. Don't bring decimals in until you have to, until you're done, really. If you bring decimals in too early, you got to carry it with you, and you're never going to represent all of them because they never end. So the minute you truncate it, you're wrong. So just don't bring them in yet. So how do I solve for C? What can I do? I can cross multiply. Do you have to cross multiply? No, but that is a nice thing you can do. This times this equals this times that. And then what can I do to get C by itself?
Divide by sine.
Divide by sine 41. By the way, there's no way in hell you can have room for both of these. I am the king of not giving anybody enough room. We're going to use all this room for number 1, so we'll do number 2 somewhere else. Kabam! So how do I figure out what C is? I put all this shit in my calculator. Just be very careful. I can't remember, does your calculator open up parentheses when you do that? Dumb calculator. It's sort of like Microsoft Word when it like tries to guess what you want to do. I'm like, stop it. I know what I'm doing. Damn it. See that it opened a parenthesis? If I don't close it, everything else I'm about to type in would go into the sign. And my answer would be freaky as shit. So I'm going to close that bad boy. Divided by sine of 41. Oh, what should I make sure I'm in before I hit enter? Yes, let me go here. I'm in degrees. Yay! So let's see what we get. Shibaba. And by the way, with law of cosines, well, I kind of gave away the game. We will have a law of cosines. And the law of sines, we're going to use degrees for our triangles. We're not going to bring in radians. That would just add too much extra shit on top of stuff we're trying to get used to. So what is this again? What does this tell me? C. So 15 point, did I say, normally I say like round to 3 or 2. So let's round to 3 decimal places. So this kind of problem, I just said we'll do these together, which is great, Ask Jeff. The instructions would say solve this triangle. And what that means is anything you don't know about it currently, I want you to find out. So we knew all the angles in one side. So we were tasked with figuring out the other 2 sides. We have one side, yes? That should be, no, Jeff, what am I doing? You guys should be yelling at me. This is not degrees. This is side C. Okay. Listen to me. That's the side, right? We didn't solve for an angle. We already know angle C. Please forgive me. Okay. So this should just be, I didn't give us any units. Sometimes I put like feet here or whatever, but we're good. So how do I get side B? Same thing we do. Sine of 41 degrees. I can do the A thing. That's the complete one I can make. By the way, real quick. Don't I have 2 sides now? Could I just use Pythagorean theorem? Why could I not use Pythagorean theorem? Because Pythagorean theorem only works for right triangles, and this is very much not a right triangle. You guys with me? Because that's the biggest mistake I see is people get the one more side and then they use Pythagorean theorem. I'm like, no, that's the whole problem. That's the whole point of law of sines. This is not a right triangle. Okay. So I can make that ratio again. That's the complete one. Now, real quick, I could make a complete ratio with C, yes? But why do that to myself? I'd rather use these with the nicer numbers, yes? Plus, I know these numbers are right. I could have made a mistake with this one. So I'm always going to go back to the one I know. And what do I set that equal to?
Sine 62.
Where'd it go? Yeah, sine is 62 degrees over B. I love it. And then we solve it the same way, yes? So maybe you guys can do this. If I multiply B up, I would multiply 10.5 up, and I would also divide sine of 41 down. Just to cut to the chase. Multiply B up, multiply 10.5 up, divide sine down. I would end up here. Now you don't have to jump like that. You can show yourself every step, but I'm running out of room. And then you just throw all that in the old calculator. Now real quick, did it make sense that C was 15 and A is 10.5? C is 15.6, A is 10.5. Did that make sense? So far it makes sense because C is supposed to be on the long side. B should be how related to A and C. What was this? Yeah, the smallest angle is 41. So A should be the smallest side, B should be the middle side, C should be the biggest side. So I know if I'm going to make a mistake. I know if I get a number that doesn't make any sense. So what do you guys get for this? That does make sense. Yes. There we go. 14.13. 1. Yeah. So is that triangle solved? Is that triangle solved? Yes. I forgot. All right, I'm gonna go get that. Yes, sir.
So we're not able to do this if we don't know the length of at least one side. Is that right?
Yeah, for, what's funny is if I didn't know the length of any side, I want you to see this. If all I knew were the angle measures, if all I knew was this was 62 degrees, this is 54 degrees, and this is, what would that be, math boy? 64 degrees, I think? Does that make sense? Yes, it does. I need you to get this. How big is that triangle? All we know is how much the mouth's open. How big is it? Like, watch this. I can literally do this. I've never thought to do this, but ooh, look at Jeff. Ooh, is the triangle bigger than it was now?
Yeah.
Are the angles the same? Yes. I wish this would have focused when I did that, damn it. There we go. Oh God. Okay, right? So if all I know are the angles, the sides could be any length. I have no way to get, there's nothing that makes the sides have to be any length. The minute I say what one side is, that locks all the other sides in. That would be like the place between there where it's 11 and then the other side lengths are set. So if I don't tell you any side lengths, you can't do shit. You guys with me? Okay. Now what I want, Christine, could you do me a favor? I forgot to, can you grab just grab 3 markers? The ones that can fit into each other. Right, they have some of those, yes?
You mean all the caps?
Yeah, that they can, like Legos. Yeah, okay. Thing. I want to do something on the board that requires that. Thank you, Christine. Okay. What is up? Go ahead and try to draw the triangle for number 2. And I kind of tell you there's a problem with it. Not an immediately obvious problem, but there is a problem. Maybe another sheet of paper. We probably are out of room by now. I'm very sorry. So C is a very small angle, right? So I'm going to maybe focus on C over here. You don't have to make it perfect, but just represent it's really tiny. And then it almost doesn't matter. This is all we have. So C is 7. And then B, you could put it wherever you want, but I don't know. I'm just going to pick to put it on the bottom. So then this is B, and this is A, and this is little a. You guys see it's relatively easy. Just try to be a little nice to yourself and try to make the angle. If it's small, make it small. If it's big, make it big, right? Try to be nice to yourself. It'll make more concrete sense at the end if it's roughly the right scale. Can I make a complete ratio? Can I make a complete ratio?
Yeah.
Yes.
C.
We. So before, I'm trying to figure out what order to do this in. Okay. Do you guys, here's what I should have done. I'll do that now. I told us how long, in fact, I'm going to do this, I'm going to do this a little different on the board. Yeah, I just realized. All right. to make it a little easier to do this on the board, I'm going to change my A and my B. That doesn't really affect the work, but it does affect what I want to show you. So, I have given us parts of a triangle. Yeah, go ahead, Ron.
I was just gonna say, if you're recording with your phone, you can.
Oh, yeah, thank you. Yeah, anybody, if you ever see something with my phone, just let me know. I don't think about it often. Get out of here. How you doing, phone? Okay. Doobie-doobie-doo-doobie-doo. Thank you, Ronnie. I've given us pieces of a triangle, and I want you to make it into a triangle. Yes? So, for example, I gave us B. I'm going to put B here. We don't know B. Yeah. Oh, wait. B is 10. Okay. I gave us that. We have a stick that's 10 feet long or whatever. You with me? I also gave us that this is 18 degrees. And I told us how long this is. So I didn't say how long this length is. I'm going to dot it in. Is that cool? You guys with me? I should have played with this earlier. I think this will work. No shit, Jeff. All right, I'm going to make it work. Okay, maybe that'll work. I did tell us, though, that this side, I could have done it here maybe. This side is 7, yes? I really want you guys with me. So, why is this side dotted? Can somebody tell me why that side is dotted? Is it just because?
Because we don't know the side length.
I don't know the side length. So I just sort of like put it in. It could be this long. It could be this long. I don't know. I just kind of put a dotted line in to show me where it should line up. But I don't know how long it is. I did say how long this side is. Okay. I gotta make this work. Do you guys see how? Does it fit like that? Does it make a triangle if I do this? Can everybody see that well enough? So if I put it right there, it makes a triangle, yes?
Yep.
What if I put it there? Does that make a triangle? How many triangles can I make given that information? How many triangles could I make? I didn't draw this to scale. I'm just trying to show you what could happen. How many triangles could I get then? I could get 1, 2. Yes? You guys see that? I could get 2 answers. Is everybody with me? Now, who took geometry and such before, like in high school or whatever? Does anyone remember SAS? SAA? Now listen, I'm not going to bring all that back, but one of them is incredibly applicable, especially when you do it in a way that the high school teachers did not want to say it. So, what do we know here? Don't we know an angle? Yes? And then the side next to it, and then the side next to it. So I know ASS. So if you know ASS, that is the problem that's an asshole. That's the problem that has a possibility of 2 triangle answers. Are you guys just on the surface level of just constructing a triangle? Can you see how I can make 2? Or I could make it so I can only have, let's see if I got it right, 1. Maybe there's only 1 triangle answer. Do you see that? Because if I try to move it, it comes off that bottom and it doesn't make a triangle. Or I could have, thank you, I could have no triangle. If I make that C side too short, will it ever fit down here and make a triangle? No, it's like up here going, shit, right? I need you to see this. This is such a beautifully physical idea. The math gets trippy, but I want you to understand the physical idea behind what we're going to have to do. We have to check, are there 2 answers, or is there only 1, or is there no answer? Now, the no answer is going to be easy, because at one step when we do it in the calculator, it's going to say, does not exist or undefined, and you're like, oh, no answer. The more than 1 answer is going to suck, because we have to check to see if another answer works. So you have to remember to do that. So the no answer is awesome, because the calculator is going to go, and you go, oh, okay. How are we feeling so far? Did that make sense up here? I mean, if that C side is not long enough, if it's exactly the right length, or if it's, ooh, let's see if this works. If it's like this, I can make 1, 2 triangles, yes? Okay. That's the physical idea of what we're about to do. What the hell is the math gonna look like? Wingardium Leviosa, no, all right. So, I don't know. Oh yeah, I'm the teacher, I should know. That's right, I do. Let's try to do this problem and see where things get freaky. So I've drawn it a different way, but it's still gonna work fine. That was just to illustrate the possibilities, just easier if I put the other one up top. I can make a complete ratio with the C's, yes? Is everybody with me? You guys all right? What happened? Okay. I can't remember what this one comes out to be. So I'm going to do this over here. So sine of what over what? The complete ratio I can make would be what? Yes, I can make a complete ratio with the C information. Sine of 18 degrees to 7, that's sine C to C. Equals, now what's the only other thing I have enough information to work with right now? Which letter do I know nothing about? A. So of course I'm not going to do A. I don't have enough information. But B, I can get it started. Sine B over 10. So now you see you're going to have to solve something for B. I'm going to have to take the inverse sine to do it. So how do I solve this? Well, I'm going to multiply by 10. And then, let me write this the other way. How do I solve for angle B? What do I have to do to both sides to get B by itself? Remind me, what do I do to both sides to get B by itself here? How do I get B by itself? Just solve for B. What do I do? Oh, apply the inverse function. Yes. That's exactly what you just said. And you're like, I don't think so, Jeff. Yes, you did. What's the inverse of divided by 7? Multiply by 7. How do I solve this for B? Apply the inverse function. Yes. Cube root dies. B equals 2. Yay. So how do I solve this for B? Take the inverse sine. Take the inverse sine of this side. Take the inverse sine of this side. What do these do to each other? It doesn't matter that they're sine. What's a function and its inverse do to each other? Cancel. Or if you say they kill each other. And then this, I plug all this shit in my calculator. I can't remember. This should work. I don't think you get a weird answer here. Did you get a weird answer, Trent? Somebody was looking.
0.441.
Oh, you're in radians. Make sure you should be in radians, I think. That would be very tricky if that was degrees.
That's the
Are you in degrees or radians? Oh, sorry. The mode button. What calculator do you have? Oh, good. You have Cassie. You look up the manual. Maybe it's easy. Do you have like a? It sounded. You have like a. Sometimes no. So maybe it's. Go to options. Get out of this thing. Options. You could always multiply by 180 divided by 5. I'm sorry. No. That's the TA84. He is a guess.
Yeah.
TIN, no. Oh, it is in degrees. Oh, I don't know. This is telling me you did it wrong. So, what am I supposed to put into the inverse sine? Sorry about it. All of this shit. So my last step should not be divided by 7. So how do I do this in my calculator, Mr. Math Boy? I put inverse sine of blah, 10 times sine 18 divided by 7. Bam. I put all that into the inverse sine. What is it?
26.196.
Ooh, what have I done? What have I done? Wait, I am in degrees, right? Yes. Inverse sine of 10 times sine of 18
Do we need,
divided by 7.
there's no reason to put a multiplier.
Oh, this might be. Sorry?
To put like times sign.
No.
Yeah, okay.
There's no reason to. I just do.
Okay.
I'm getting an error. What did I do here? Oh, I have one extra. Leave me alone, calculator. All right, 26 point, we'll say, yeah, 2 degrees. All right, so on, all right, this is gonna be exciting. Let me see if I can highlight this. I wish I would have drawn this the other way, but it's too bad. Well, we just figured out we got B, and B is the angle that's down here. So if this is here, let me see. Oh, wait. If this is here, B is big. If this is here, I'm sorry. If this is here, B is smaller than 90 degrees. Let me see if you guys see. That's angle B, yes? How do I know that's angle B? Because that's side B. So we just got, if it's here, it's one thing. If I swing this over, what's true about the angle here now? Is that bigger than that one? Which angle is here? Which angle is bigger? This angle is way bigger. Isn't he bigger than 90 degrees?
Yeah.
And that's smaller than 90 degrees. So the one we just figured out is this one. Sure.
Yes.
The second triangle, if it exists, would be if I swing that in. Now, a great question is, how the shit do I swing this in mathematically? Mr. Waller, if that's really your true name. Well, here's how it works. Thank you for service. Let's see. This triangle is isosceles. How do I know that? Because this side is equal to this side. In fact, in our problem, it would be 7. That's the C side, yes? And what kind of triangle has a side equal to another side? Isosceles. So even if you forget the name of it, isosceles, if this stick is as big as this stick, this mouth is as big as this mouth. So what this would be 26.2, yes? All right. You ready for an explanation how silly math people are? That's an angle, yes? That's more than 90, yes?
Yeah.
This is an angle.
Yep.
This is an angle. How many degrees? 180, totally. So this is 180. This is 180. That's 26.2. What's that? 180 minus. So how do you check to see if another triangle might exist? You take the angle you find and subtract it from 180. That's the first step. I really want you guys with me. This is trippy. I will tell you directly, this is trippy. I really hope that helps. The physical reality of what this is. Here's the work we got to do. That's why I did this. There we go. If I do 180 minus 26.2 degrees, what do I get? Yeah, 153.8. What other angle is already in the triangle from the beginning? What other angle was already in the triangle? 18 degrees, yes? If I have a 153.8 degree angle in there, does it leave room for the last angle to exist? What does that mean, Jeff? Does this plus 18, does it go over 180? No. You can add it, yes? Okay, no it doesn't, because 180 minus 26 was there, so 153 plus 18 is less than 180. So let me try to reiterate what I just said. I get an angle. I I do 180 minus that angle. Yeah, so now I'm saying that this angle, here, I can do this up here. I'm not gonna take you guys are here, so. This angle then is 153. 18, you're just a little overzealous. This is what do we say, 153.8? Does that triangle exist? Yes, because do these two leave room for a third one to exist? Yes. Now, real quick, just to show you. If the answer we got here was like 170, what's 170 plus 18? Could that triangle exist? Because it's over 180 already. So then you would have one triangle. So I know one triangle has this angle. The other triangle might have this angle. How do I know the second triangle exists? Because if I put that triangle in, that angle in, it leaves room for the third one. The third one has room to exist. So when would it have zero answers? When the inverse sign we just did? Well, let me show you. To have zero answers, way over there, Jack. Oh my gosh, I miss when my eyes worked. Here's what it would look like. You would get this. So as long as you typed in everything correctly. So just to show you, when I was first typing this in, I was getting this error. No, I don't want a graph. Syntax error. That just meant, in this case, I had put an extra parenthesis, yes? So just to really make sure I really want to help you guys out because this is freaky enough already. If I type in an inverse sign and I get this error, if I typed in everything correctly, that's telling me no triangle exists. That's when the little dude is just dangling up here and you can never connect. I can't construct a triangle. They didn't give me the right size things. I can't make a triangle. Make a shed. Well, you didn't give me the right size stuff. I can't make a shed. Oh shit. So that could happen. It's a physical thing. I can't make it if you don't give me the right size pieces. What else could happen? I get an answer, like 26.2 degrees. Then I do 180 minus that. That is the mathematical equivalent of swinging it over. That's what that step is. And then I go, oh, did that leave enough room? That plus the angle I know is not 180. It left enough room. A second triangle exists. Y'all look very excited. You're like, I was wondering how this guy can make this stuff worse. Now, personally, I love this shit. Of course I do. I love that idea is actually relatively easy to get the physical nature of it, I'm hoping. You can see if I make that little dude too short, he ain't never gonna connect. How could you make a triangle if you can't connect it to the other side? That makes physical sense. What does it look like in my calculator? My calculator goes, shit. It says domain error. Meaning the number you plugged in was too big. We just didn't know it until we tried it. Yes? All right. So how many triangles are answers to this question? 2 triangles. So what could there be? None? And that would be an immediate error. 1, I get an angle, but it doesn't leave room for another angle to exist. Or 2, I get an angle, this angle leaves room for a third to exist. And now you really see why I said tricky. When do I know I've got to do any of this shit? When I have angle, side, side. Which in high school they said side, side, angle to be safe. And I'm like, no, let's just say what it is. Okay. So how do you finish this up, dear God, Jeff? How would I do it? I don't know. Oh yeah. Here's what you want to do. We basically did all the same steps we did earlier. But if you look back at our earlier work, we didn't take an inverse sign. We didn't have to because we already knew all the angles. That's why there was only one triangle there. It wasn't ASS. That's actually, can you see it still, Jeff? This was AAS, SAA, something like that, yeah, okay. I don't care about the A's and stuff, who cares? All right, here's what I Very much recommend. We've identified this as second triangle, yes? Yes? So B1 is 26.2 degrees. B2 is 153.8 degrees. So I desperately try to get you guys to be nice to yourself. I have 2 triangles worth of information to figure out now. So I am going to keep them separate. I'm going to label 1s and 2s, and I'm going to focus on one triangle and get it done, and then go do the other triangle. I'm going to try to make it as nice as I can on myself. So can we finish up the first triangle? This guy, don't worry about him. If B1 is 26.2, if B is 26.2, what is A? Can you guys figure out what A1 is? If angle B is 26.2, what's angle A? 155? 135? Okay, that makes more sense. Is that right? 135.8? Okay, 162. Yes, cool. Thank you. What else do I have to figure out still? What's the only thing I don't know in that first triangle? In the first triangle, I know all the angles, and then I know 2 of the sides. So what's the only thing I have left to figure out? Side A. So let's see, side A. How do I figure out side A? So now we know B is 26.2. Let me kind of redraw this. We know B is 26.2. We know little b is 10. We know angle A is 135 degrees, 35.8, and we know angle C is 18. We know that from the beginning. So can I use the law of sines now again? Yes, so I'm going to use C again because that's the one we knew from the beginning. Sine of C over little c, Jeff, it's 7. Good job, buddy. And then I still need to know what A is, so I put sine of A over little a. So in this triangle, do you guys see that side A is going to be the biggest side? Very much so, because he's got the biggest freaking mouth. 135-degree mouth. So then we already know how to solve this. We just have to cross multiply. And then divide. And then slap it in the old calculator. Calculator. Oh shit, get out of there. Okay. All right, tell me what you get when you get it.
15.719.
Yes. I want to put units on there, but it didn't put any units down, damn it. So that triangle, and I'm going to put A1, just to be really clear. Triangle, the first triangle is solved. And the great thing is, if there's going to be one good thing, dear God, let there be one good thing. All the work we did here, we're going to do the exact same work, but I'm going to use that angle instead for B. So then for this second triangle, what's angle A? Because the angle C we knew from the beginning. Yes? So for the second, so we got the first triangle done. We got all the angles, all the sides. For triangle 2, how do I figure out angle A? Right, just add these two, see how much is left over from 180, right? What would that be, math boy? 8.2. Is that right? Yeah, thank you. So if you add these together, and then subtract that from 180, you see what's left over for the third angle, yes? And you get a little tiny 8.2 degrees. Little tiny 8.2. And again, if I come up on the board again, this is angle B in one situation, and this is angle B in the other situation. So like angle A, if B is big, A is small. If B is small, A is big. That's exactly what we're seeing here. If B is big, A is small. If B is small, A is big. Yes?
Yeah.
Because when I swing it, I change both angles.
Did we ever get little A two?
We did. Sorry, Ronnie. No, little A1. We're just now working on the second triangle. So I finished the first triangle out entirely because, trust me, you don't want to try to do both triangles at once. You get some of one shoved into the other one and you get weird things happen. So now I'm going to try to focus on triangle 2. So I can set up, again, another, I don't really need to, but I will. If I redraw this, so the angle B is big and angle A is tiny. I can still use the same ratio from the beginning. Yes? That's the one I knew from the beginning. So I know sine of C, Jeff, it's 7, is equal to, and what's the only thing I don't know now? We knew C from the beginning and we knew B from the beginning. So we still don't know, we don't know A. So all the work we did before is going to be the same as what we're doing now, except I'm going to use 8.2 degrees for A. Instead of the big one, it's the small one. Okay, I don't know if you guys are really with me. The math and the physical reality actually kind of line up if you let it. And we've done this enough. You cross multiply, you'll eventually get to this, and then you just plug that in the old calculator. What do you guys get? Anybody get something? I get 3.23. Yeah, okay. All right, so I'll leave that up there. Can I please get my, who are my little sleepy pandas? And do I have any sleepy pandas? All right, can you guys see each other? Can you guys maybe come up here for Sharma and just grab a seat next to her? Where are my completely not derpy horses? Okay, it's Layla and Ronnie and Ilion. You're also a horse. Okay, I knew one group has 3. So Ilion, Ronnie, and Layla. Can you guys agree on a place to be? Maybe you guys can go over there and kind of like pull a chair up in front of Ilion. Where are my living avocados? Okay, I've got many and right here, Ethan. So maybe go either way. I'll let you guys find it out. Fight you to death. Where are my completely not derpy chickens? Okay. Oh, here we go. Okay. So you guys, I don't know, go somewhere. You come to the other. Okay. Is that everybody? Did I get all of my animals and such? I think so. So let Christina or me know if you need any help. Okay, like this. This is all right. Where you guys find chickens? Okay. Try to work together.
Okay. Well,
So it should, well, all right. I don't remember how I made this, but I'm pretty sure one of them must have more than one answer or something. One of them is where you have to check. Yes.
So, step one, two, what's the ratio? So you do 6, 11 times
And then we'll go with 4 So guys, I'm gonna start to catch up to you, but we're gonna have a quiz tomorrow.
every second
I
I
do apologize. It's been a little busy, but we'll have a quiz tomorrow. When is our next test scheduled for? Do you guys know? Next Thursday. Yes, the 7th. So on Wednesday is review day. So on Tuesday, I'm gonna have the practice test for you. Yes, you guys all with me? Yeah. So we have to have a quiz. Well, actually, it could be. It's the 7th Thursday. We'll start there. Is the 7th Thursday? Let me see. I was just looking at a calendar, and it's really funny.
Yeah.
It is Thursday? Okay, so I have I'm gonna practice some democracy in the classroom. You guys ready? If I do a quiz tomorrow, it'll be 8-1, 8-2. If I do it here, this is what I was writing earlier, and then I decided not to. If I do it tomorrow, it's 8-1, 8-2. If I do it Tuesday, it'll be 8-1, 8-2, 8-3. So it's up to you. What would you rather? What would you rather? 8-1, 8.
Would it be the same amount of questions, or would it be different?
Probably one more question at least on that one. Oh no.
I vote Tuesday.
Choices, Jeff. Why? How many want Tuesday? How many want tomorrow? Oh, this is neat. This is neat. All the tomorrow people, we have a special place in my heart. How many don't care? How many don't like raising their hands for anything? All right, 3 of you abstained from everything, so I'm not sure to make it. All right, so we'll have it Tuesday then. It's fine with me. It'll just be on more stuff. Yeah. But you know, it does give you a little more time if you're behind at homework. Okay. Just to make sure you guys understand, 8-1 and 8-2 were both graphing. If I remember correctly. Yes, graphing, sine, cosine, graphing, tangent, cotangent, cosecant, secant. And then 8-3 was the inverse stuff. So all of that will be on the quiz next Tuesday. If you wanted the quiz tomorrow, I am sorry. So let's take a look. I'm gonna catch up to you guys. Here's the first problem. And if your triangle doesn't look the same as mine, it doesn't matter. You just want some kind of a visual anchor. Just make sure that one angle I'm given it kind of makes sense. It's big. So I can set up, can I make a complete ratio? Well, I can make a complete ratio using the B's, yes? Okay. I was gonna ask if I was alone in the room. Am I having a lucid dream again? Okay. Sine 11 degrees over C. You guys with me?
Oh, yes.
The only other angle I know is C, so the only other side I can get currently is side C, because I can make a partial ratio for it. And then I cross multiply, and at the end that can come up, that goes up, that comes down. And what do you guys get for that? Did anybody get that? What have I done with my calculator? Oh, there it is. What'd you guys get? Anybody? 4, 5, 4.87. Sine 11 divided by sine 124. You're like, do you not trust me, Jeff? No, I trust. I trust you, bro. 4.879. Okay, cool. And normally I would put some units on there, but I just didn't on this one for some reason. So now we know C. We got C.
I think I have one.
What's angle A, by the way? I was being kind of silly when I said that earlier.
93.507. C 55.
Oh God, I thought you were telling me what it was, Trent. I'm like, no, that is so wrong. What's happening? So yeah, what is angle A? Do it again.
C 16.
45?
Same math.
See, 130.
Okay.
Oh, this is 124. Why did I say 0.2? What am I doing there? 124 degrees. Yeah, 135. So that would be 45. Yes, okay. I'm sorry. It took me a second to catch up to you. And the only thing I don't know yet is side A. I don't know side A. So now I can make that same ratio again with the stuff I knew from the beginning. Oh, I see why I put a 0.2. But now I want to do sine of A over A. Now that happens to be a nice angle, but just throw in the old calculator, yeah? So A will be, the 21.2 comes up, and then divide by the sine 124. Just to show you, do you see how this is almost that? The only difference, come back here. The only difference is that should be 45. So if I hit second enter, I can go back and make that 45. Ba-boo! Is that what you guys got? 18.082? Yes? Okay. And does that all make sense? The largest angle was B. That is definitely the largest side. The smallest angle was C. And that is definitely the smallest side. And between the both of them is A. So that makes physical sense. You can always double check mouth size versus stick size. Okay. I like it. So now, of course, the second one should be where weird should happen. I'm sorry, Trent, did you need that? You're good?
Yes.
Okay. Second triangle should be where weirdness happens. Let me zoom out a little bit. Just a touch. Oh, there I am. There's my units. Go past Jeff. So this is indeed ASS. So if I kind of draw it for myself, make A about 31 degrees. It doesn't really matter. So this has got to be A, which is 10. And then feet. And then C is 16 feet. Why are you talking like that, Jeff? I don't know. Leave me alone. This would be C. And this would be B. Okay, I think I got everything on there. Yes, 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 yes. Just left your units off, Jeff. Okay. So if I set up my complete ratio, I can make a complete ratio with the A's. And then I can make an incomplete ratio with the C's. Now, obviously, inverse sine is the one that makes this not quite work. So when I have to take an inverse sine, that's kind of like the signal you might have to check. And why does it make sense? What is inverse sine's outputs?
Angles.
They live, they live between what angles? Inverse sine. What can it give you?
1 to 180. No.
Negative, be just a little more specific. Negative pi over 2 to pi over 2, yes? Inverse sine is quadrant 4, quadrant 1. You with me?
Yeah.
Now think about what I just said. Inverse sine can only give you outputs up to 90 degrees. So if the triangle has a bigger than 90 degree angle, inverse sine can't do that for me. The thing it gives me is a reference angle then. Because it's not even physically capable of giving me an angle bigger than 90 degrees. That's another reason why a second triangle might exist. Because inverse sine can't give me all the angles that might happen. So if I do this, multiply the 16 up, and then take an inverse sine of both sides. And slap all that business in the calculator. Did anybody make it to this point? What'd you get, sorry? 55? 0.49? It's not that I don't trust you. I just like to see it happen. It's just always neat to me. 55.493 degrees. And that's C1. So what, if there is a second angle, what would it have to be?
180 minus that.
180 minus that. What is that? 124.507. Could that work with the angle that's already in there?
Yeah.
How do you know? What does that mean? What do I mean? Could it work?
180 minus both.
These two add up to be less than 180. Okay. So now let's go back and focus on this. So now I know this works. I have to get that eventually. If C is this and A is that, can I get what B is?
Yep.
Yep. So if I do 55.493 plus, what was it? 31. And then I always do this minus 180 and it's just take the negative off, but you don't have to do the weird shit I do. 93.507 degrees.
Yep.
And by the way, these are all a little bit wrong because we did round, but I don't care. It's close enough for government work. And that's exactly what I do. Now, what's the only thing we don't know then? What's the only thing we haven't figured out? We know side C, side A. We know all the angles. Side B. So if I do the same thing we've done for a while, but now I know B is 93.507. Okay, so do you see how the work is really repetitive? Which on one level makes it kind of boring, but on the other level makes it easier to remember. Right? In mathematics, boring is very often good. From a student's perspective, I guess. I don't know if you guys agree. B, so then this would come up. This would come down. And then I end up with, oh boy, it's time to go. Damn it all. Divided by sine of 31. I get 19.3797, so that'd be 19.380 feet. All right, so in the actually, what time is our class supposed to end? 2:30, I thought.
Yeah.
Well, that's true.
It was.
I should give you a 10-minute break. Give it to you at the end of class, which I'm going to do right now. So we'll finish up the second triangle tomorrow, and then tomorrow we'll also. Did anyone consider this? Why can't I use law of sines on this?
Because there's no ratio.
There's no complete ratio. That's whenever law of sines won't work, law of cosines will. So tomorrow we're going to prove what the law of cosines is.
Yay, Jeff!
All right. I'll see y'all tomorrow.
Thank you very much.
Quiz Tuesday. Don't forget. Did I start you back up? I did.